there's a whole theorem that gives you the connection between the indefinite integral and the definite integral. And that theorem is the fundamental theorem of calculus. Let's see what it says. Suppose that you have a function which is continuous on a closed interval, and continuous is very important here. And also suppose that capital F is the antiderivative of this small f. Then the fundamental theorem of calculus says the definite integral, which we define like this, from a to b, or f of x dx, is nothing more than the antiderivative evaluated at b minus the antiderivative evaluated at a. Okay, so f of b minus f of a. Let's see an example. Suppose that we want to find the definite integral from 0 to 1 x squared dx. The only thing we need is to find an antiderivative of x squared. And that, of course, is x cubed over 3. Notice that we need to take just one antiderivative, not all of them. So we don't really need the plus c here. Choose c equals 0, let's say. So by the fundamental theorem of calculus, you have then that the integral from 0 to 1 x squared dx is nothing more than the antiderivative over 3 from 0 to 1. This notation means the antiderivative evaluated at 1 minus the antiderivative evaluated at 0. Let's write it up over there. This can be written as f of x from a to b. Okay, that's just a shorthand notation that is very, very helpful. So what does this mean? It means x cubed over 3 evaluated at 1, so 1 to the third over 3, minus x cubed over 3 evaluated at 0, so 0 to the third over 3. And this, of course, gives you 1/3 minus 0, and the answer is 1/3. Okay, that's your definite integral for this function. And note, of course, that the plus c never came into play. So actually, that's always the case. The plus c always cancels out. So it's not really needed in this calculation.